Welcome to another Great Cow Basic tutorial. This is part 7 of the Great Cow Basic tutorial for the PIC18FxxQ41, and we're working through a whole series of videos. So we've covered 6 so far, and so far we've covered setting up LEDs, making the switch work, reading the ADC, making them the LEDs rotate in sequence, and now we're going to add some reverse by just some basic logic, and we're going to bring this, the pieces that we've learned so far all together in one program. So what am I using? I'm using a microchip low pin count demo board, and you can do exactly the same on a Curiosity Nano board, the red one. I've got, let me have a look at my lab here. I've got one of these. It's the same. It's just flipped around the other way, and I've got it connected up to my programmer, and it's quite useful because it's got the LEDs, etc. So that's pretty good. The layout is like this, and it's there so you can copy it, but we're going to use the pot today. Let me just bring my pen up, my pointer. We're going to be using the potentiometer here. We're going to be using the 4 LEDs and this switch here. Can I use anything else? Oh, that's about it really. I'm actually going to use the programmer that's attached here to control the voltage. So we're going to pull the whole thing together. So what do I mean by pulling it together? We're going to use the LEDs as outputs. So we've got an output on the microcontroller to the LEDs through resistors, and we're going to make those rotate in sequence. We've got an input, the input in terms of the switch, and we're using that as an input, not as a master reset. So when I push the button, it's not going to reset the chip. We've got that set up. We're going to read the ADC, which is the voltage across the potentiometer, and we're going to scale that value, and we saw how we scaled that value earlier on, so we've got some control over what we do. And we've used time. Now, we're not using a timer as such, we're using calculated time that is consistent across all the microcontroller frequencies. So if you say wait 1 millisecond, it will wait 1 millisecond, irrespective of what you specify the frequency of the microcontroller. And we've seen that in use, and we're going to use that again. So what we're going to do, we're going to initialize the board. Great Cow Basic does a lot of that initialization for you to keep it very simple. Flash an LED just to say hello, and then we're going to do something forever. And essentially we're going to read the ADC, and then we're going to go one of two routes. If the switch state has changed, it will go one way, go down the left, and it will set the state of the LEDs and loop round again. But if you press the button at this point here, it will come around here, and then it will wait and then loop back again. All right. So we've got this double loop in here, and all it's going to do, it's going to make the LEDs move one way or the other way. It's not sophisticated, and we're going to use this demonstration and this sequence more and more because we can use interrupts, we can use serial, we can use a lot, and we can teach a lot through this one demonstration. So let's have a look at that code and see how it all works. So here we go. If I get into my editor here on my second screen, so what we've got is the complete program listed here, and we've seen this before. We've got the chip specified hash chip, and then it's the specification of the chip. And if you use a different chip with the same board, you just change that, and everything else will work for you. Option explicit, it means that you have to define your variables. And we've seen all this before. This is a little diagram of the port layout. So it shows you I've got something connected here, an input on A3. Let's update that for us. Let's get that absolutely. We've got the switch connected to A3. SW, I'll put that in there for us. I'll delete that. Let's just make it look absolutely perfect. There we go. On port B, I've got nothing connected. And down here, I've got 4 LEDs. So I've got a switch, an ADC, and 4 LEDs. Great. And I've got some constants. I've defined some constants down here, and we've been very consistent about not changing those. And I've said that the switch is an input by having the direction of the switch in called in. And then we're into a program, okay? And the main program commences here. It says quite clearly. And what we're going to do is define some constants for up and down. that's 1 or 0, and that's quite useful because if you're pulling the switch up, it will need a different value if you're pulling the switch down. So it's useful to have two a constant up and down, because you might actually have those inverted on your particular board. Well, I'm going to have some variables, and I'm going to have a direction variable that says which way the LEDs are rotating. I've got a variable for my delay, which will be the value of the ADC that we're going to read in. That's the proportional voltage of the on the ADC. And I've got a variable called LEDs, and that's going to hold the state of our LEDs. And essentially, I'm going to move the bit through, my finger, I'm going to set it up as 1, then rotate it to make it 2, then 3, and then 4, and back, like that. So 1, 2, and it's just going to rotate through, like, backwards and forwards. And I'm going to do that in the variable to make it really simple. Okay. Okay, so I set up my initial state of my LED. I'm using a macro, we used that right early on, and a mask. And why do I use a mask? Because my LEDs are quite clearly only the 4 of them. And a byte holds another 4, so I just need to mask off and just talk to the lower 4 all the time, okay? And I do that by having a mask, and I'll show you how to use that in a moment. And then I set the initial state. I'm saying turn the first LED on. So let's get started. I'm going to read the ADC, and I'm going to put it in the variable called my delay, and then I'm just going to take the value as it comes out. Okay, it's in the range of 0 to 220, because I've got a resistor on there, and you can check that with your meter. Have a look at what the maximum voltage is, and the maximum voltage on mine happens to be 2.2. And so I'm then saying scale that to 1 to 200, and it just makes sure that I never go to 0, because the delay of 0 is very, very long. So I just want to make sure that if I return a 0 voltage, I've got a small delay, not 0 delay. Then I've got an if statement that says if the direction, and the initial direction is set above. You can see it at the top of the editor here. The initial direction is to the right. If the direction is right to the right, move the LEDs around. Okay, we've seen that before. How we move one bit, to the next bit, to the next bit, to the next bit, and when it gets to the end, it just resets it and goes around and around and around. Well, if it's not the right and it's been swapped by our switch, it then moves it the other way around. And the code in there says set the first one, set the second, set the third, set the fourth, and if it's got to the end, reset it back here, and it's the same the other way around. Very simply done. And then I've got so if my delay, it could never get to 0, so we can take that out. It says wait my delay for so many milliseconds, and then it just checks the switch. And if the switch isn't, if the switch has been depressed, then just reverse the direction. And the code down here is the same as we saw yesterday, which is all about managing the state of the LED. So essentially what we're doing is, if the switch is pressed, go to the left. If it's pressed again, go to the right. Wait a minute and do it all. Wait a minute, wait a millisecond, so many milliseconds, and do it all again. So I'm going to press function key F5. We're going to see on the screen the LED road flash as it programs it, and then it starts to walk. Put my finger on here. Just turn the secondary light on. I'm just going to rotate that potentiometer, and it gets faster. And so that is now at 1 millisecond, and that is at 200 milliseconds. There we go, per change. So let's put it somewhere so we can see it. There we go. If I push the button, the LED now goes in the opposite direction. I push the button again, it rotates through. So We've seen the potentiometer being read. We've got the direction being changed by the switch. That switches into the master clear, which we're not using as the master clear, which is absolutely great. So it's a really simple program, and we can use this later on. We can use this to change this to an interrupt. So when I push the button, you can change that and you can raise an interrupt. And when you raise an interrupt, you can actually reduce the amount of code. But it's a more complex program to understand. So the goal here was to pull this together into a consistent program. And this example is reverse LEDs with a variable delay. It's actually code 090, and that'll be going up on the web today. So let's go back to PowerPoint. So tomorrow we're going to use exactly the same code that we've been using today, but we're actually going to be using the serial to display the values that are hidden away inside that microcontroller. And with Great Cow BASIC, that is extremely simple. So enjoy.